Hello Year 10, I hope you're all doing okay. Welcome to this video which is going to talk you through the answers for the displacement and distance worksheet that I set you for your week 1 forces topic. Okay, if you've not attempted this yet, I would encourage you to have a go. It will help you with your understanding on doing these calculations, and you should be able to have at least have an attempt at some of these questions. Okay, we're going to need calculator and a ruler for answering some of these. Okay, so make sure you've got those to hand if you want to follow along. So just obviously there is some maths in here, so we are referring a little bit, and I'll come back to that in a minute, referencing some of your maths understanding as well. So let's talk about this first of all. Okay, both are measured in meters, so we know that any calculations we do today are going to be in meters. Okay, we're talking about a swimming pool. So it says a man swims in circles around the swimming pool. Okay, so that's pretty important to remember. He wants to know how far he's travelled at certain points. It says calculate the distance travelled between, first of all, these different points. Now we know that distance, okay, is just the route that they take, the path that is taken. Okay, so all we need to do for these first questions is to add up the distances that he has swum. Okay, so for A to C, we know that he has travelled, let's just get the ruler out of the way, he has travelled all the way from A to C. Okay, and we know that that is 500 plus 500 meters. Okay, these distances that you can see are between the 2 points on the sheet. So for the first one, he has travelled 500 plus 500, which equals 1,000 meters or 1 kilometer. Okay, for the second one, he's travelled from A to F. Now we know that he's travelling around the pool, so he's using all of this route and then all of this route. We've already said that this distance here is 1,000 meters, and we can see that this distance here is 600 plus 200, giving us a total here. I'm actually just going to add this to the diagram of 800 meters. Okay, let's do the same here, because we are going to need that reference. 1,000 plus 800 gives us a total of 1,800 meters. Next we're looking at A to G, so G is this point here. Okay, again he's circling around the pool, so all we're doing is adding another 300 meters to the route he's already taken. Gives us a distance of 2,100 meters. Next it's asking us B to H, so from here round to this point here. Okay, so we know that B to C is 500 meters. We know that C all the way down to F is another 800, and we know that F all the way to H is going to be 700 meters. So we're going to add 700 on there. Okay, that gives us a total of 500 plus 800, which is 1,300, plus 700 is a total of 2,000 meters. Hopefully that's clear so far. Next we've got the distance from F to A. Now, it's a rectangle. We've already said that from A to F is 1,800 meters. So we would say all the way back should be the same, but we're going to check it just to be sure. So 700 plus 300 confirms that all the way across here, let's do that in slightly different, is 1,000 meters, and 700 plus 100 up here is 800 meters. So correct, we have 1,800 meters, and then finally from H to A is our final distance. We've got 800 plus 300 gives us 1100 meters. Okay, hopefully that is clear. Second question says, if he swims around the pool 4.5 times, how far has he travelled? So, how far is it all the way around the pool? Well, we know that it is 1000, 2000 plus 2 lots of 800, or this distance twice, so we can say that 1 equals 3600, which is 1800 times 2. Okay, therefore 4.5 times equals 16,200 meters, just over 16 kilometers. Okay. Now we're going to move down to some of the questions a little bit further on. Okay. So now it says, now find his displacement between the following points. Remember, displacement is the shortest distance from where he started and requires a direction. Okay. So let's start with the easy one. Okay. A to C. The distance and the displacement are still the same. The shortest distance between A and C is the distance that he travelled. So it's still 1000 meters, but we have to remember a direction. We're just going to put to the right, okay, with an arrow to the right would be fine. You could say to the right. If we knew that this was north, south, east and west, we would be able to say, but we can't, so we're just going to say that it's 1000 meters in that direction. Now things get a little bit more complicated, okay, because we're going to cross the pool. And this is where we need to bring in some of our maths understanding. So you'll be thinking now about Pythagoras theorem, okay? So if you recall about Pythagoras theorem from your maths, where we're talking about triangles and the square of the hypotenuse equaling the sum of the squares of the other two sides of a triangle, okay, that will give us the help that we need to calculate these displacements. So let's take the first one, and this is where we're going to draw on our picture. I'm going to use a different colour just to kind of make it a bit clearer. So this time I'm going from A to F. Okay, now my triangle is still along here and down here. And remember what I said about Pythagoras theorem. Okay, so this is the hypotenuse, and it is equal to the sum, okay, so the square of this is equal to the sum of the squares of these. Okay, but we don't want to know the sum of this, we want to know the actual number. So when we get that number, we will need to square root that number. So let's work through it carefully. Okay, so we know that A to C along here is 1000 meters, but we're going to want to square that. 1000 meters squared is 100,000. Okay, and then this distance between C and F, this end of the edge of the triangle, obviously is 800 meters squared, which is 640,000. Okay, so if we add those two numbers together, 1,640,000, we get the sum of this line. What do we need to do? We need to square root it. Okay, and if I get my calculator again, if any of you are not sure whether you've got a scientific calculator, the easiest way to find out is to turn your calculator to the side, and hopefully it should turn into a scientific one. Okay, so remember what I said, our value is the square root of 1640000 and gives us a reading of 1281 meters. Okay, hopefully that's clear. If you're not sure, rewind the video and go back and check what I've done. Okay, I'm just going to go over that for you a bit clearer. So we're going to work through each of these in the same way. Okay, so A to G, we've got a different, let me use a different pen colour this time as well so you can see it. So we're going down to here this time, so we're going to draw a line here, we're going to draw a line up. Okay, this time we know that we've got a couple of slight difference. Okay, our distance here is still 800 meters squared, or 640,000 as our sum, our square. Here it's not quite the same distance, it's 300 meters less. So this is 700 meters squared. Okay, I'm just going to do that really quickly, just so you know. Gives us 490,000. Total is therefore 1130,000. And I can end up with a reading of 1063 meters. Okay, so that was for the third one. Let's look at this fourth one. Okay, I'm going to change the pen colour again. This time we're looking at B to H. Okay, B to H. Let's draw our distance. Now, where's the easiest way to do this? Well, we know that distance there. Okay, we don't know the distance here, so we're going to take our reading off of this. Okay, again we know the distance of this side. We've got our 640,000 value, which we've got there. Okay, and we've got there as well. Along here, what we know is that this distance is 500 meters minus that distance there. So this is only 200 meters squared. 200 meters squared. Okay, which is 40,000. And hopefully you can see how this is working. So again, we're going to do it this time. We're going to do, I'll put this here so you can see, a square root of 40 plus 640, which is 680,000, gives us a reading of 825 meters. Okay, so that's B to H. Next we've got F to A. Now we would hope, we saw before that F to A is the same distance. Okay, it should of course therefore be the same displacement because we are travelling back the same direction, so we can assume that it is 1281 meters. Finally, the last one, let's find if I've got a suitably different coloured pen, is from H to A. Okay, so this time we're going from H to A. Again, I think we're going to use this distance here and this distance here. We've got 300 meters squared and we've got 800 meters squared. So, last little bit. Okay, 300 meters squared gives us a reading of 90,000. We already know that this distance here is going to give us our 640,000, gives us 730, so we're looking at the square root of 730,000. And a displacement of 854 meters. Now, there was a lot to take in there, guys, okay? Complicated, and my sheet looks a mess. So please do go back and stop at different points. There is, of course, one thing I've missed. We haven't put a direction on any of these, okay? So we need to draw an arrow next to each of them to show the directions, okay? A to F in this direction, A to G at a slightly sharper angle, B to H this direction, F to A going back up, and H to A in that sort of direction. Okay? Right, let's do the last part. He swims from point A to point B to point D for a chat with a friend. Calculate the distance he has swum. Very simply, 500 plus 250 equals 750 meters. Calculate his displacement. We're going to do the same method again. Pen. So this time we're going to go. You'll notice now that I'm over the top of everything, so you won't be able to see anything now. Okay, 500 and 250. So we want 500 squared plus 250 squared. $250,000 plus $50 times 250. It should be. I'm just checking. Yep. 62,500. Okay. Good. That gives us a total of 250, 312,500. So if we square root that, it gives us a displacement of 559 meters. Okay. So you can see the displacement is shorter than the distance, which makes sense. Okay. If he completes 3 laps of the pool, calculate the distance he has swum, calculate his displacement. We know that 1 lap is 3,600, so times it by 3. Equals 10,800 meters. And then the last thing, calculate his displacement, is a slight trick question, because he has gone all the way round and his start is here and his finish is here as well. So our answer is 0 meters. Okay guys, loads there to take in. Okay, quite complicated. Let me know how you got on with it. I will be interested to see your answers. If you have any questions, please do let me know. And I will see you next week.